the x minus 1 to the third power. And the inner, you guys told me, is x minus 1. The outer is x to the third power. And now we're going to rewrite this as, if you let the u be the inner function, and the outer we're going to rewrite as u to the third power instead the x to the third. But we see as something to the third power, and that something is the u. And the derivative of the inner is 1, right? The du dx equals 1. And this, the derivative of the outer function, the derivative of u to the third with respect to u is 3u to the second. So to find the derivative of the function y with respect to x is the product of the derivative of the inner times the derivative of outer. But usually we're going to do the outer first, which is the derivative of u to the third with respect to u, and multiply by the derivative of the u with respect to x. So this one from the outer, this one from the inner. And then we put them together. The derivative of u to the third is 3u squared. And the derivative of the inner is 1. And every time you do the substitution, you're going to use the u substitution and bring everything back to the original set of the variable, which is the x. So therefore, in this case, you have 3 times the u is x minus 1 to the second power as the derivative that we are looking for. Okay, so that's pretty much the way that it works out for the chain rule. And the pattern of the derivative, there are two different versions. The version that I just showed you is a product of the derivative of the inner and the outer. By you have to identify first what is the outer function, what is the inner function. It's easier to work on the inner function first because you take whatever the one that tuck into the main function, and the main function would be the outer function. Okay, like let me pick up the example that we can go over real quick. So for part A here, we have y equals the 2x to the third plus 5x, the quantity to the power 6. We can see this, the inner function is the 2x to the third plus 5x, and the outer is the power 6, the power 6. You can treat this as your inner is 2x to the third plus 5x. That means the entire function y can be changed into the form of the u as u to the power 6. Okay, so this is your outer function, and this is your inner function. Kind of identify what inside, what outside, and then the derivative dy by dx gonna be the derivative of the outer function with respect to u multiplied by the derivative of the inner function with respect to x. It's kind of the chain or the link. As you see the notation du by, sorry, this is dy by du, or the d of the u to the power x, power 6 over u. So you can see this as a link or the chain to combine them together. But if you think about the two fractions multiply each other, you can cross them out, right? But this one you have two separate notations, but you can treat similar way. And the final form would be the derivative of u to the 6, which is 6u to the 5th, multiplied by the derivative of the u, which is 6x to the second power plus 5. Substitution back with the u as 2x to the third plus 5x to the 5th, the coefficient 6, and from the derivative of the inner function, put them back together to be the derivative of this function. Okay, so it's hopefully it's not too confused. Let's take another example. Like the last one here, e to the power tangent x for this slide. Sorry, so you can treat this as the inner or the tangent x. So e to the something, right? E to the something. Your something is your inner function. Okay. So put on the side here, the u is the tangent x. And we're going to find the derivative of the outer function, which is the e to the power u, by the derivative of the tangent, which is the secant square of the x. The product of these two derivatives is the derivative that we are looking for. And the last step, replace u back into the problem. So we have e to the tangent of the x multiplied by the secant square x as the result. Okay. Identify first what outer, what inner, and then find the derivative of each. The last step, bring it back into the form. And another example here, the rest of them you can use the notation u to represent the inner function. Like this one is the cosine of the x to the second power. And we can treat like, what is the inner? The inner we let it be u to the power second. And make a list on the side here. The u is cosine x. And find the derivative, multiply by the derivative. So y prime equals 2u multiplied by negative sine x. And at the end, change the u in the terms of cosine x and you are done. Okay. Part F, y equals cosine of x squared. This is the same as cosine of something, and your something is your inner function. Okay, your inner function or x squared. The derivative is the derivative of the outer multiplied by the derivative of the inner. This is negative sine of the u, derivative of the u, which is 2x, and change the u in terms of x squared, and you are done. Okay. For the second, the last, not the last one here, the one before the last, the y equals sine of something. And what is your something? Just ask yourself. Your something is e to another something, where another something, like you have like three pieces tucked in together. You have sine, you have exponential, and you have algebraic. Go in one layer at a time. The first layer or the outermost layer is the sine. After you get into the sine, the one next inside is the e. And the one within the power of the e is 1 minus 2x. So in this case, you have three layers of the function composed to each other. And with the three layers, I'm going to get rid of this real quick. So take this one out of the way. So that means the y prime gonna be the derivative of these three layers. Okay. So y prime, I'm going to line them up. Y prime. So next step gonna be the derivative. So y prime is the derivative of the first layer, multiply derivative of the second layer, and multiply by the derivative of the innermost layer. So the derivative of sine is cosine of the u. Derivative of the u with respect to v is e to the v. Have to keep an eye on the variable in each group of the function, like the first one with respect to u, second one with respect to v, the last one with respect to x. So the derivative of the v is negative 2. Okay. And after you are done multiplying by all derivatives of each portion of the function here, you have to get back to original x term. We call the v is 1 minus 2x. Okay. That means this term will be replaced with e to the power 1 minus 2x multiplied by negative 2 here. This step is going to simplify. And the first function is the cosine of the u. What is the u? U is e to the v. And what is the v? V is 1 minus 2x. So you have to substitute back twice for the very first derivative because it's the outermost layer that has more things tucked inside of it. And after you are done plugging it back in, simplify as much you can or write in the appropriate way as negative 2 times e to the 1 minus 2x times cosine of e to the 1 minus 2x. So that's pretty much the chain rule when you have more than two layers of the function composed to each other. So the tip and technique is to identify what inner, what outer, and find the derivative of each one, multiply all together, and then replace it back into the x term if you transfer into the new variable u. The second version is I say is the traditional version. That means you go from the outermost, don't worry about the inside, bring everything inside, and then After first layer, you go to the second layer and then go in for another layer until you are done. Um, for the second part, if you give me 2 minutes, I'm gonna go through this real quick. Um, the for example, the first example here is the concept problem that you would use. The second version, like the H is the composed of the F and G. You can write as F of G, and when you find the the H prime at 1, so find the derivative of the H is the derivative of the outer function. The outer is the F, the inner is the G. So the outer function derivative is going to be F prime, whatever inside, multiplied by the G prime, whatever inside. Think about the outer function. Outer function has the input as the gx. You do not change anything for the input of the f prime. But for the g prime, since already go inside another layer, gonna be just the g prime of x. So the same concept as the first version, that you use the product of the derivative of the outer multiplied by the derivative of the inner, but use different notation. That's it. But for the concept problem here, you are going to use the input as the original and then bring in more and more terms after you see the numbers. That is going to be f prime at g at 1 multiplied by g prime at 1. And then from the given number, the g at 1 is 2. You're going to work on the f prime at 2 multiplied by g prime at 1. And pretty much to multiply two quantities together. The first one is the tricky one because you work on the outermost function. So f prime at 2 is 6 and the g prime at 1 is negative 2. Multiply to get negative 12 for the h prime at 1.